Okay, today we'll be here to look at how to solve a old past year PSLE 2009 maths question. The question is as follows. Jim bought some chocolates and gave half of them to Ken. Ken bought some sweets and gave half of them to Jim. So Jim ate 12 sweets and Ken ate 18 chocolates. The ratio of Jim's sweets to chocolates becomes 1:7, and the ratio of Ken's sweets to chocolates becomes 1:4. How many sweets did Ken buy? So we will proceed to explore two methods of solving this question. The first method will be via bar modeling. So initially, when Jim bought his sweets, he gave half of them to Ken. So at the beginning, Ken and Jim both had the same number of sweets. The same for chocolates. Ken bought the chocolates and gave half of them to Jim. So both Ken and Jim had the same number of chocolates at the beginning. So hence we draw the bars for sweets and chocolates of equal lengths. But Jim ate 12 sweets. So we have to reduce the bar for Jim's sweets by 12. So that's highlighted by the yellow box, yellow square box with the number 12 inside. But do remember that after we subtract the 12 sweets, what Jim has left will be this dark blue block. And if you add 12, that will be equal to the light blue block, since both had equal numbers of sweets at the beginning. So we will call the dark blue block 1 unit. And based on the question, after Jim had added the 12 sweets, his ratio of sweets to chocolates was 1:7. So 1 unit equals to 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we just show you the yellow box to illustrate what was the initial number of sweets, and after he had eaten 12, we have this dark blue section left. Then we look at Ken. Ken had bought some chocolates in the start and he gave half to Jim. So at the start, the amount of chocolates was the same for both Jim and Ken. But Ken ate 18 chocolates, so what he had left was this section of the green bar. But Ken did not eat any of the sweets, so this section was untouched. So we'll call the sweets that Ken has at the end, call it one part. So it's one part, and this is the number of chocolates that he has left. Based on the question, we know that at the end, the ratio of sweets to chocolates for Ken was 1:4. So one part equals to 1, 2, 3, 4 parts chocolate. And this section will be equals to 18 since he had 18 chocolates. Yeah, so just a reminder, this portion will be equals to 1 unit and the 12 sweets that he ate. And this portion, which is equal to the top portion, will be 4 parts plus 18. So since we know that 1 part is equal to 1 unit plus 12, so we bring it down, and each of this is 1 part. So each of this will be equals to 1 unit plus 12. Right? So from the block diagram, we can now see that this portion here is equal to the portion above. Right? So we look at the diagram again, just the relevant sections for chocolate. You can see that 7 units, which is this 7 units, is equals to this portion, which is 4 units plus 12 plus 12 plus 12 plus 12 plus 18. So if we bring the 4 units over, we have 3 units, which is equals to 66, and 1 unit equals to 22. So the question was, how many sweets did Ken buy? So the total number of sweets would be the combination of these two bars, which is 1 unit plus 12 plus 1 unit plus 12. So we have 2 units plus 24, and since each unit is 22, the solution will be 68. So Ken bought 68 sweets altogether. Do remember that 68 sweets includes the top and the bottom bars. Another more direct way of solving the question would be through algebra, which may be beyond the syllabus of the primary school students, but it's nonetheless a faster method and good to know. So here we let X be the number of sweets that Jim bought, and we let Y be the number of chocolates that Ken bought. So from the question, we know that Jim gave Ken half the sweets and Ken gave Jim half the chocolates. So right at the beginning, these were the sweets and chocolates that each of Jim and Ken had. So X is number of sweets, so it's X over 2. Half of the sweets were with Jim, half of the sweets were with Ken. Same for chocolates. Half of the chocolates were with Jim and half of the chocolates were with Ken. So then the next part of the question mentions that Jim ate 12 sweets and Ken ate 18 chocolates. So for Jim, so we subtract 12, so it's X over 2 minus 12. And for Ken, he ate 18 chocolates, so it's Y over 2 subtracted with subtract 18. Right, so this is how we express the number of sweets and chocolates that Jim and Ken had after they finished eating their respective sweets and chocolates. So here we see that the ratio of Jim's sweets to chocolates becomes 1:7, and the ratio of Ken's sweets to chocolates becomes 1:4. So that means, first we look at Jim, the case of Jim. The ratio of Jim's sweets to chocolates becomes 1:7. So 1:7. So to derive the equation, we just have to multiply this portion by 7 times. 7 times X over 2 minus 12 will be equals to Y over 2. We multiply by 2 throughout, and we solve for this section, and we get Y equals to 7x minus 168. Similarly, for Ken, we can derive another equation. So Ken's ratio of sweets to chocolates will be 1:4. So for every 1 sweet, there's 4 of these. So it's 4 times X over 2 will be equals to Y over 2 minus 18. So we reduce the equation. So 2x equals to Y over 2 minus 18. Bring the 18 over. So you have Y over 2 equals to 2x plus 18. And you divide by 2 throughout. And you get the second equation, which is Y equals to 4x plus 36. So the first equation is Y equals to 7x minus 168. The second equation is Y equals to 4x plus 36. Since both the left-hand sides of equation 1 and equation 2 are both Y, so that means we can just solve directly for x. So 7x minus 168 from equation 1 and 4x plus 36 from equation 2. So that brings us to 3x equals to 204 and x equals to 68. So the number of sweets that Ken bought is equals to x as defined right at the start, and which is equals to 68 sweets. I hope that helps students understand the two different approaches to solve this question. Thank you very much.